Hello and welcome to Nuremberg and to our ARM Tech Talks live from Embedded World 2024. I'm your host, Tobias McBride, and all week, together with some of our incredible ARM partners, we're bringing you a glimpse at some of the groundbreaking ARM innovations at this show. This ARM Tech Talk series is the place for you to discover the latest trends, technologies, and best practices from the ARM ecosystem. So welcome back if you've watched our series before, and thank you so much for joining us. We're live every day, bringing Embedded World to you at home, at work, wherever you are around the world. Our partners are showcasing some of the latest developments on what is the world's most pervasive and efficient compute architecture that 70% of the world's population uses. That, of course, is ARM. And we're going to be highlighting some incredible AI-powered use cases at Embedded World and really showing that the future is built on ARM at Embedded World. Now, talking of ARM and talking of AI, one of the great partners of ARM showing the power of ARM, and particularly our Helium Vector extension set that helps accelerate those common AI and DSP use cases on device, is Ambiq. And I'm delighted to be joined today by founder and CTO of Ambiq, Scott Hansen. Scott, come on the camera. Thank you so much for joining us.
Thanks for having us.
So, talk a bit more about yourself. Tell us a bit more about yourself and Ambiq, and then we're going to talk a lot about Edge AI.
So I am CTO and founder at Ambiq, as you mentioned. Ambiq was founded to put intelligence everywhere. Okay, yeah. It's in the name. Ambiq means ambient IQ, ambient intelligence. And the idea was we want to put low power silicon absolutely everywhere. And ARM has been our partner since the beginning. So we're here today at Embedded World to launch the new Apollo 510 microprocessor.
It's super exciting. I can't wait to see the demo of that. But before we talk about the demo, before we see this demo live, and is it the live demo? So I'm sure we'll all go smoothly. There's no hiccups, right?
Smoothly, no
absolutely. So what is your take? What is your approach to Edge AI? And really, what does ARM play? What role does ARM play in your Edge AI story?
So there's two things that are really difficult about Edge AI. One of those things is power consumption. You've got such limited resource in these little devices. You've got a battery. How do you fit it all in? Ambiq is, of course, the vendor that provides the lowest power solutions on the planet. We've got a proprietary Spot platform that allows us to do that. But ARM is, of course, the lowest power vendor out there, right? The M55, which is the architecture we chose for Apollo 5, takes us to a whole new level. So you've got, as we'll talk about later, the Helium Vector unit enables amazing energy efficiency. So we'll get to that here in a moment. The other big thing is usability. So there's this perception that neural network development is difficult. Right. That, of course, is not true. I'm having a talk tomorrow where we'll talk about why it's, in fact, quite easy to do these days, but using the ARM core makes it a lot easier, right? This is a well-developed core. The software ecosystem is amazing. You've got SimSysNN with all these pre-optimized libraries. So the ARM solution for us was the most energy efficient and the easiest to use.
Awesome. Well, let's talk a bit more about this great demo here and talk a bit more about why you chose it to do build Apollo 10 on ARM, 510 on ARM. So to do that, let's switch cameras and let's see this demo live in action.
Perfect.
So I'm just going to switch over here to our mobile mic camera. There we go. So, Scott, why don't you talk us through a bit more about what you're showing off here?
Okay, so we have, on the left, we have our Apollo 4 Plus board, and it is running a neural network that's doing onboard image classification. So it's running through a bunch of images, and it's identifying what is in that image. We have the exact same neural network model running on Apollo 5. This is actually an engineering version of the board. The ultimate production version will be small like this. It is running on the Apollo 510, which has a Cortex M55 at a slightly higher frequency. But there's two things to note here, okay? We're running about 10 times faster in terms of frames per second on Apollo 5 versus Apollo 4. A small bit of that uplift comes from the higher frequency, but the big lion's share of that is coming from the Cortex M55. You've got the Helium Vector unit. It's running 8 max in parallel. You've got a big wide memory bus that's feeding that and big memories on board Apollo 5. So quite a bit more performant. The bigger thing, the more important thing from my perspective is you're spending about 1/3 the energy for every inference that you're running, okay? And so some of that for sure comes from the more efficient Cortex M55. It just runs inference quite a bit more efficiently. Apollo 5, though, was actually designed to be, despite the fact that it's a bigger, better core, it was still designed to be more energy efficient. So even if you're running while 1 on Apollo 5, it's going to end up consuming less power than Apollo 4. So between architectural enhancements and circuit enhancements, this is quite a bit more efficient than our previous generation. So if you are running signal processing, if you're running inference, this is the platform for you for sure.
Awesome, awesome. Well, let's talk a bit more about Helium Vector extensions. Is there anything else you can give us insight into maybe some of the, let's geek out a bit with Helium Vector extensions there. So talk about what you're doing there exactly with them and how they're so great.
One of the things we were really hungry for with Apollo 5 and with the M55 in particular was wider memory bandwidth. So we needed wider memory buses, but also a wide MAC unit to go with it, right?
Yep.
Having a wide MAC unit doesn't do you any good without the wide memory, and having a wide memory bus doesn't do you any good without the wide MAC unit. So we're very excited about that. You can do as many as 8 MACs per cycle. You've got support for half precision and single precision vector operations. You have support for scalar double precision operations. So very, very exciting use cases there. The thing we of course also love is the software is relatively easy to run. You've got SimSysNN, as I mentioned before, so it's easy to use the intrinsics or to use SimSysNN directly and make use of that Helium Vector unit. There is, as I was just talking about before this discussion here, there is support for auto vectorization. So if you've got code and you don't have time to go in and use the intrinsics or map to SimSysNN, you can auto vectorize right there.
Awesome.
LLVM supports that. Very exciting stuff.
Awesome. It's really great to see, as you say, that scalable platform you've got from Apollo 4 right the way up to Apollo 510. We'll talk about that a bit more in a minute. But as you can see from some of these stats, I mean, the M55 is running just at a blur of inferences a second, and the Cortex-4 is still doing great. But it's great to see your use of Helium, etc. So
yeah, now, there's one actually quick point I want to make on that.
Of course, yeah.
Not every application needs this performant neural network performance. Sometimes what you need is a lightweight, low-cost system that can run a lightweight neural network. And so we support inference across the full Apollo lineup. So from Apollo 3, which is Cortex-M4 based, to Apollo 4, Cortex-M4, on up to Apollo 5, that's M55 based. And in the future, you can expect to see much higher end support even yet than that.
Yeah, we'll talk a bit more about the future in a second, but thank you so much for that demo. Well, let's talk a bit more about TrustZone actually and security, right? So let's go back to our main camera and talk back to the, now we've done the demo, and thank you for showing that. Let's now go back to talk about TrustZone, right? So this latest product also integrates TrustZone, as we talked about. But I'd love you to talk a bit more about the reasons you felt that TrustZone integration was so important for this Edge AI product family.
So we've talked about the promise of endpoint AI. It's all sounds wonderful, but you start adding microphones and cameras to these devices.
Yep.
Customers and consumers get concerned about security, right? I'm putting my health data out there. I'm putting my motion data from within my home out there. Security becomes a top concern. So when we designed Apollo 5, there were really 3 main focus areas. Energy, of course, that's what Ambiq's DNA is. Performance, we just talked about how important that is, but security was the third leg of that stool. So with the integration of TrustZone, suddenly we have support for trusted and untrusted code. So you can have an app store that supports both trusted and untrusted code. You can have secure software blocks that have been certified, FDA certified or whatever, and we've got support for all that. In addition to the TrustZone support, we've also got all the other security knobs that you need. So we've got support for secure boot. We've got a whole secure lifecycle management flow, and this is absolutely the most secure part we've ever built.
Absolutely, and we were talking a bit more beforehand actually about how customers have specifically requested this as well, which is...
Yeah, and it's become a showstopper for a lot of customers. They come in and say, look, I need TrustZone. If we're going to continue using this, we need this. And so we had to provide it. It was something that had been on our to-do list for a while, and we're happy to finally have it out there.
It's super exciting to see. It's really great to see the integration of Helium and the integration of TrustZone to talk about that secure Edge AI deployment on the edge. Now, as we look ahead, love talking about the future. Where do you see the future of Edge AI going? Where do you see that collaboration between ARM and Ambiq and the future Edge AI going?
Well, excuse me, it is going to happen both at the software level and the hardware level. So at a software level, it's really critical, as I said earlier, to support AI across the full spectrum of Ambiq's products, right? From Apollo 3 on up to Apollo 5. You don't always need an NPU. You don't always need a vector unit like Helium offers. Sometimes what you need is support for a 10 or 50 or 100 kilobyte model on your low-cost MCU. So we have a whole software roadmap that provides all the tools you need. We provide what we call AI development kits, which are pre-built neural networks that include all the weights, all the model itself, all the training data to make it easy. That gets coupled with SimSysNN at a low level, and you got everything you need to go. Now, that's not everything, though. You need hardware support, right? And so, of course, M55 is a big part of that push. You're going to see higher end products that are launched with more memory, with more processing capabilities. We're excited to see the new Ethos U85 launch that you guys are disclosing here. So expect to see Ambiq pushing the limits on the high end as well with future product launches.
We can't wait. We absolutely cannot wait. Now, to about Apollo 510, I'm sure people on the call are going to, and on the live stream are going to say, this sounds amazing. Yeah. How can I get my hands on one of these?
So we, our first customers already have access to that silicon. You'll see products from them very soon. We're really excited, and we're heads down in supporting that. We will have broad support in late Q3 this year. So you want access to that silicon and a board. Please come see us. We're here at Embedded World. We're over in Hall 3 at booth 301. Or come see us here at the ARM booth. We've got a great demo on display here. We've got people on standby.
Absolutely, yes. Do go along to that booth and do check out the ARM booth as well. So, Scott, thank you so much. This has been a pleasure talking about all things Edge AI, and really excited to see that live demo all work smoothly as expected. So thank you so much, Scott. And that concludes another ARM Tech Talk live from Embedded World here in Nuremberg. And as I said, we're live every day discovering the latest innovations at the show, all based on ARM. So subscribe to the ARM YouTube channel so you don't miss any of our upcoming talks. Thanks so much, Scott. Again, absolute pleasure. Thank you, audience, for joining. And we'll see you again for our next ARM Tech Talk later today from Cadence. And we'll be talking about a lot of exciting stuff there and throughout the week about how the future of AI really is being built on ARM here in Nuremberg at Embedded World 2024. See you soon.